Hi, everyone. So I would like to show you something. Wait a sec, a bit disturbing. Okay, so what you have seen now is this new user interface that we are preparing, still in development. What we are also preparing is a different kind of access to the archive, which is a programmatic and tool access. So you don't do things really, well, you can also do through tools things graphically, but the main idea here is that while the web user interface allows a certain amount of queries, the ones that are part of the query model of the application, here we want to provide also access to our databases in a much more open way, such that you can use your fantasy, your science cases to really perform the queries that you want to get better, to get closer to your science aspects. Wait a sec, how do I move from here? Yes, I need to. Yeah, I will not print, don't worry. I want to have a proper way of, okay, fighting. Slideshow, will it turn? Of course not. Why that? Wish. Okay, here there is something. I get there. Oh no, not each page. Yeah. But now the one will be turned, right? Wait a sec. What's happening here? Start video. Thank you. Thank you, John. Oh, it went away. Sorry, it's not my laptop, and I did not prepare this morning. I was not here this morning. Very sorry. Well, but you can stop that. So this is, and so I go, but then I cannot move. And then this comes in, I hate it. Sorry? Which? Yes. But okay, fine. So I'm back in Safari, clearly. What happened to preview disappeared? It crashed? Oh, thank you. Okay, listen, I will go over like this, okay? So, what I was saying here, basically the idea here is that you can do complex queries, not just the queries that are prepared for you by a web user interface that does a lot already, but here we really open up the databases. You can do complex queries, and you can also, if you want, program your queries such that if you have repeated, you have to repeat your job several times to check, hey, is my data there, is my data there, is my data there? You can program it and program any query, actually, even the complex ones, and basically have everything scripted. The other part, apart from the programmatic access, is that you can use the same interfaces to this programmatic interface to use tools like Aladdin, Topcat, etc., to query directly from the tools, not passing the information from the web interface to the tool, but already from the tool you can do the queries that you want, and you get the results immediately in the tool. All this is done through VO standards and protocols, well established, and for us, using the VO protocols is also a way to ensure that, I mean, we give more visibility to our data, because there could be other tools out there that automatically connect to the VO. We will register all our applications when we go public to the VO registry, so all the tools will automatically discover without even us publicizing more. The tool can discover, ESO has data like spectra or images or cubes, etc. And so it will be a way to increase the usage of our archive. So here I will show you just a couple of these complex queries using this VO standard that are called tabular access protocol, using this ADQL, which is the astronomical query data query language, is a SQL based. How many of you, can I ask you, how many of you know SQL? 1, 2, 3, 4, 5, 6, 7, 8, 9, a dozen. Okay, good. Though possibly you don't really need to know, but better if you know. I will show you examples, and I will show you how you can edit the examples, change the examples to learn how to do things. The focus here for this demo, but not only for the demo, but for this first release of our project is phase 3 data, what Jorg showed you before. But through programmatic access, you can also program access to the raw data, though in a more limited way. And you have also access to ambient data, seeing isoplanatic angles, etc. So, okay, there are a number of things that I cannot demo because this is the first release. Not everything is ready in the first release. We will do other 2 releases in the next 2 years. Let me just move on. So I have prepared this demo page that you can use anytime if you are within ESO. You cannot externally, not yet. That will become available only when you are when we are public. And this demo page, let me open it there. It's a web page just to illustrate the concepts. Okay, explaining at the top which standard we are using, such that you can click on those and learn more if you want to know that. If you want to program things, maybe it's good to also read this documentation. Then there is a purple area where you can play with individual data to get different things. But now the focus for me is that here, this is the part I want to focus now, is how to get access through TAP, through this tabular access protocol to our archive. I have prepared here in this bar, you see a number of examples that you can look at. This is one of the most complex because I want to show you first the complex stuff, but you can find many different examples that you can read, execute, change, execute again, etc., to learn how to do things. Let me just give you a first interesting example. Maybe we go back later to simpler stuff. So, for example, what you cannot do using a web user interface typically is this kind of query. So you are interested in building a color magnitude diagram. So you want to find images or source tables in different bands, provided that, of course, they overlap in the region of interest. So this query here that might seem a bit complex, but I'll try to illustrate now. Can you read that? Maybe I go back to, because I have it here, maybe it's easier. This is the same query. So this strange query here, you have in the front part, you're building 2 tables here. This is the J table, the table that contains around the galactic plane, plus or minus 10 degrees. It contains, for all OCI data in around the galactic plane, we are looking into source tables, and they must contain the J wavelength, so the central wavelength of the J band. So basically here we're saying, give me any source table around the J band, around the galactic plane for Okai. This is joined with the other table that we build on the fly. Same story, Okai again around the galactic plane, this time for the H band, and again source tables. So these two are joined thanks to this intersect here. So basically the S region fields are our footprints. So the source table as a footprint, the J footprint must match the H footprint. So you have a match, they intersect equal 1 means they intersect. So those are good candidates for your color magnitude diagram. Not only, this is an ESO function, as you can read, is an ESO function that we added to the ADQL language to compute actually the extent of the overlap. You're not interested in, of course, if the two source lists overlap just in a little corner. You want to be sure that the overlap is significant. So it's 80% of the area of one of the two. So this query, notice, is a wool sky query. So, okay, a wool galactic plane query, but it goes onto the wool sky. And it executes very fast thanks to the SQL server we have behind. Now let's see if it works, of course. Now I'm just giving back text, sorry, I selected text, so okay, fine. You see, it's very quick and you get back your results. Now, I take this query and did you run already? Let me see. Do we have already running Aladdin? Where is it? It was running. So where is the, how do I call it? Oh, this thing is annoying. Go away. Thank you. Okay, so you prepare an alias. Okay, good. Yes, what I have to do, I have to prepare the tool. As I told you, we are not yet public, so the tool cannot discover that we yet exist, so I have to add this information. Now, in this demo page, I've put all you have to do is all described there. What you have to do, basically what I take is these two lines, go back to Aladdin, paste, and magically here on the left, appear our entry. So you expand, 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 and okay. This is the way the tool looks like. So this is Aladdin showing me the top interface to the ESO archive. Here I can, sorry, I need to go back there and get back the query again, which was this. Now I'm selecting the J band out of that, of the ones that match. I put it there and submit. And as you can see here, you see the progress of the query, currently 200 loaded, 1,000, and there you go. I should have loaded first maybe DSS to see something nice. Okay. So as you can see, so we got all the source lists available that in the J band, those are the J, so what one should really do is to go there, select properties, to remember J source lists, something like that. I can also click here on show all associated field of view. This is a Aladdin way of saying, okay, when I zoom in, for example, here, I will see also the shape, the real footprint of that thing. So let me zoom in, zoom in, zoom in. Okay, so here now you see the footprint. Now you can select this, and you will see that it's actually not a single footprint. You see that there are a number of source tables there, all in the same place, with different limiting magnitudes. And you find here all the properties that are known. So the spatial resolution, so you can also select by what I didn't show you. In the query, you can modify the query. You can say, okay, give me only the ones that have an AB maglim greater than, or show me only the ones that have a spatial resolution better than, and so on and so forth. So in this case, I let those parameters free, but you can do that at the query level. So here I focus on the second one because it's nicer, or even this one is a bit better. So here, what is shown in this entry is that there is actually a link there. We call it data link as another VO standard. A data link is a way to say, okay, I have identified this source table. Tell me which files are available for this source table. So you click on it, and the data link is queried, and return in Aladdin is shown this way. If you use Topcat, you will receive a table in Topcat itself. And here is telling you, okay, the requested file, so this source table is 4 megabyte size. If you click, you load it. So I click, and I load it. So the source table is coming directly in Aladdin, and you see already the sources there. I can zoom in. I can maybe remove, sorry, wrong layer, this layer. I can remove now the field of view because we see the data directly. And not only for the same entry, I click again, and the second entry here is the file used to generate the requested file. So this is the image out of which the source table was built. Now here you don't see more information, but if you load it in Topcat, each tool presents information in different ways. So in Topcat, you will see that there is actually written which science category, we call it, data category this file is. So it's a science image. And you can also notice that it's much larger, but I can click on it and load also the image. And while loading, it is blinking, so it's still loading. I'll also put the source table on top, otherwise I will not see the source table once the image is loaded. So basically, here you see how you can do both queries using TAP. I show you how to do a complex query in a browser. But while this is loading, I show you more in the browser. In the browser, okay, this is a commodity software. So it's for me just to illustrate things and for you to learn. If you want to do it programmatically, you can. You take the same query and launch it programmatically. How? For example, you click here on the show the URL, and basically here at the bottom, this complex thing is the URL that you should be putting into your program, wget or a Python that connects to the web. You execute this and you get back in your program the results. In this moment, I have chosen as output format text, but you can use fits, TSV, CSV, etc. You can use ViewTable. The VO will typically use ViewTable, but depends what you like and what you prefer. So this is a way to learn how to modify the query. So you can say where the maglim is and AB maglim greater than 25.7 or 8 or whatever, and so on and so forth. Of course, you will do the same also on the H band. And you click again here and you get a new URL. And so you know how to interact with the system. So in the meantime, here I have the image loaded. And of course, the first thing one has to do is to change the log and local cuts and close. And then you will see a much better match between the image and the actual source table that was computed out of that image. You can do the same. This was the query for the H band. You can do the J band. You can do the same query again in the tool for the other band, the H band, and load the images here and continue. Or even use HJ, maybe find a K, and using LaDen, you can build a color image of the 2 or 3 images that you choose. Wrong button. Another query I want to show you, don't look at the query. It's too difficult now. But just to tell you that other things are possible. Now, what I want to show you, I start from the result, it's easier. Okay, maybe, can you still read? Okay, I stop here. So this is a query to combine ambient data, the seeing from the mass instrument, to the PSF with a maximum measure onto an OCI product. So I chose an OCI product, it's actually taken in the KS band, and I query with that complex query that I'm not going to explain now, but if you want, you can ask me later. And basically what I show there, in one single query I get, the last column contains the list of all the raw files that participated in building that OCI product, that OCI image. So those are the raw files. Out of the raw files, I get the start time of those raw files. And for each start time, I find out around the start time, I query plus or minus 3 minutes around the start time. And I find that there are 3 measurements in the mass seeing. And the average of the mass seeing is 1.003 in this case, while the PSF measure onto the OCI product was 0.74. So, and you can see the table that shows the results for all the raw frames. So basically, this is useful to do trend analysis or to check more what was the ambient information available at the time of the observation. Of course, don't be scared by seeing this difference in numbers. So the PSF with the maximum is measured onto a KS image, while the mass seeing is in the optical. So of course you have to take into consideration the wavelength. So you have to do the ratio of the wavelength multiplied by 0.2, elevated at 0.2, etc. So you have to know the model, but you can bring this down back to and you can compare the numbers basically. So I think, okay, one other thing, I don't know how much time I have more, but, come on, 6 minutes, okay, I can relax. I'm sorry? Oh, pizza's getting cold, so that's important. I'm Italian, so. Okay. Here, this system also illustrates some simple queries for you to discover what are actually the tables that are available in the system, to understand what are the tables that you can query, what are the columns in those tables that you can query, what are the units, the formats, and everything, so that you can really investigate how you want to investigate. So in this simple case, so tab schema is the essential schema where all the metadata for all the tables and columns is stored. So a query to the tab schema means I want to discover what is that you have, how you offer it. So in this case, I simply query the tables, the tables of tables, the table of tables, and I want to know their name and their description. So maybe I take HTML output, and so basically you see that here we offer all the ASM is our ambient service monitoring. So all the ambient tables, but we have also this ops score, which is okay, this is a VO standard. It's a VO standard, is an important VO standard because it describes the physical characteristics of all your data, being them images, spectra, etc. And the beauty of this table is that many observatories have built their ops core service. So meaning that all services look alike. They are really identical. So it's a standard. So you can think of building a physical query to find the data of a certain kind and send the same query to all the different observatories. And the same query will work. And you will get back whatever you get back, but then you can combine things. So you can find, for example, well, of course, if you query for, you can query for the J band, give me the J band. You will not find it in the X-ray, sure, of course. You modify, you get something else for the X-ray. But you can query just by position, all the different archives, and by position, of course, you will get an answer. So you can get X-ray answers, you can get, and that, by the way, you can also do it by this little interface, because here I put a list of services that support, for example, OpsCore. So the same query, you can run it in Canada, you can run it at MAST in Baltimore, at Chandra, etc. Once you discover which table is of interest to you and you say, I'm interested in reduced data, you have read the description, it was written, this OpsCore is useful for reduced data, so okay, then you click here and say, okay, what are the columns, the types, the unit, the UCD for that OpsCore table. Again, HTML, and run the query, and you discover that you have always available abmaglim. Oh, sorry, abmaglim is not a standard thing. I have added 4 little things because they're useful. So abmaglim, SNR, and a few others that I will have to document here. So don't try an abmaglim against Canada, but because that will not work. But most of the others, apart from 4 or 5 of them, are common, are really part of the standard. And as you can see, is written here OpsCore, so this means that this is part of the standard. The ones that don't have OpsCore are not. And so here you discover that you have available the spatial resolution, the time resolution, and so on and so forth. So it's a way to discover. You see here which one are in seconds, which one are in days, which one are in degrees, etc. So you can use TAP to discover what TAP is all about. So that's the beauty of the system. And you can also do investigative queries, like, for example, you want to know, let me see what is more useful. You can query, okay, show me for each collection that you have, how many data products you have for that collection, or how many of the different data product type, how many are available in each collection, and so on and so forth. So you can really discover the quantities that we have available, like the aggregations are doing on the web user interface that Jörg showed before. So here with this query, you can discover that there are images and spectra, etc., in the different collections that we have and how many there are. So this is an interactive way of discovering programmatically, if you want, instead of using a web user interface. But you can also do that. It's handier. This, of course, in the user interface. I'm really available for questions. If you have more questions, I don't think I will continue. The pizzas are important.
Let's thank Jörg and Albert. Do you have any questions for Jörg or for Alberto? If not, then do we have any of our participants online that have any questions? All right, let's thank our speakers of the morning again.